So we were doing binomial expansion. This is what we started with last week, and we were done with most of the concepts that we need to know for this topic. Today we will be doing the last thing that we need to know about this, and then you can do more practice over the next 2 days. And let me know if you have any problems. We can discuss them in class. Otherwise, we're going to move on to the next topic in the next class, depending on if you have any questions or not. Okay. All right, so some of you have asked me about recordings. I told you earlier that I would be uploading the recordings over the weekend generally, but since you've been asking about it, what I'm going to try and do now is I will be uploading them twice a week from now. Okay, so once the recordings are going to be uploaded on Tuesday or Wednesday, so one of these 2 days. And then again, they're going to be uploaded over the weekend. So you will get Monday and Tuesday's recordings uploaded by Wednesday at the latest, or maybe Tuesday night. And then the Thursday's recording will be uploaded by the weekend, maybe Thursday night or Friday. So you'll get those recordings then. Okay, so that's about the recordings. I will try to I'll try to upload them twice a week now. Okay, so I'll be uploading Mondays and Tuesdays, hopefully by tonight or maybe latest by tomorrow, inshallah. All right, so this is what we did in the last session. We talked about the formula that we have for binomial expansion that looked like this: a raised to power n plus nc1 a raised to power n minus 1 into b raised to power 1, and so on. This is what the formula looked like. In the formula sheet, we have a slightly different form in which they use this notation, n1, n2, n3 like this. We need to be familiar with this notation as well. We need to understand that n1 like this means nc1, this is nc2, and this is nc3, and so on. Okay. So this is what we did. And we did a number of examples. We did question number 1 from the worksheet, this one. We did question number 24 from the worksheet. That's one of you asked about. And then we did question number 3 from the worksheet as well. These were 3 questions that we did in our last session. Now, today we need to do a very important concept, and that is finding a specific term in an expansion. Okay, finding a specific term in an expansion. And after this, you should be able to complete this worksheet. All right. So let's talk about this thing. Finding a specific term in an expansion. That's the key thing that we want to do today. And we're actually going to do this using this example from the worksheet. That's question number 2 from the worksheet. Okay, let me just open this. All right, let's understand that using this example from the worksheet. Question number 2. Okay, so what does it say? It says, find the coefficient of x in this expansion. There's a slight misprint here. Let me just correct this. It's 3x minus 2 divided by x whole raised to the power 5. I'll write that again here as well. It's 3x minus 2 over x whole raised to the power 5. Okay. Now we are asked to find the coefficient of x in this expansion. We need to find the coefficient of x in this expansion. We do not have to expand it fully. There is only one particular term that we are interested in, and that is the coefficient of x. That's all that we want. Okay. Now, how do we approach problems that like this? How do you figure out what to do in problems like this. That's what we want to do now. That means finding a specific term. Okay, I missed term there. So we're looking for a specific term in an expansion. Okay. Now, the idea is we are just going to use the same formula as before. We're not going to do anything new. We will just be using that same binomial formula to figure out this term. And I'll tell you how you can make this process quicker by actually figuring out which term it is directly. Okay, by the way, is anyone hearing a lot of background noise? Or is it okay because I have some children playing in another room and I hear their noise in the background, their voices in the background? Do you hear them as well? Is it distracting? So I'll tell them not to, or maybe I'll tell them go somewhere else. Anyone else who can hear any noises in my background, any voices in my background? Yes, no? It's actually amplified by the fact that you guys don't speak at all. So
it's not distracting.
okay, all right. Thank you for letting me know. Okay, so let's look at this. 3x minus 2 over x whole raised to power 5. We need to find the coefficient of x. Now, how do we go about this? This is the formula that we have. Remember, this is NC1, this is NC2, this is NC3. All we need to do now is we need to use the same formula and expand this thing. Let's see what happens when we do that. So what's the first term? The first term is a. In case of a, we've got 3x. The second term is b. In case of b, we have minus 2 over x. And then we have a power on that. That is 5. Okay. Let's just input values and see what we get from this. A raised to power n. So a is 3x. So we have 3x whole raised to power 5 plus nc1. We're looking at the second term now. nc1, what's that? N is 5 into 5c1 into 3x whole raised to power 4 into minus 2 over x. Now, the idea is you're not going to do the full expansion. All you are going to do is you're going to expand the first 2 terms, expand up to the first 2 terms. And now there's something interesting that happens whenever we do a binomial expansion. And that is that the powers of x have some kind of a pattern. Now, what is that pattern? Let me show that to you in some of the previous examples that we did. For instance, we did this expansion. So we did not do this fully. Okay, we can't find that pattern as in it is there, but it's not very obvious here. But it'll be obvious in this example. So basically what happens is the expansion that we have, it always follows a certain pattern. What's that pattern? The powers of x are going to be in a linear sequence. They're going to be in a linear sequence. What's a linear sequence? An arithmetic sequence, an arithmetic progression. You've done that. If you haven't, you've done this in O-levels already. Linear sequence is one in which the difference between consecutive terms is constant. That remains the same. So for instance, if you have x raised to power 2, and then the next one is x raised to power 5, what's the difference between powers? It's 3. You know for sure the next term is going to be x power 8, the next is going to be x power 11, the next is going to be x power 14, and so on. If you have the first term as x raised to power 6 and the next one is x raised to power 2, you know for sure that the difference is minus 4 here. So the next term has to be x power minus 2, the next one has to be x power minus 6, then the next one has to be x power minus 10, and so on. The difference between the terms always remains constant. It's a pattern that we have in binomial expansion. Now, how does that help us? That helps us because now we can actually figure out where exactly we are going to have this x term now. We can pinpoint where x is going to be. So let's figure out what the power is in the first term. What's the power that we have in the first term? It's x raised to power 5. So the first term has x raised to power 5. What about the next one? What about this term? What's the power of x in this term? Can anyone tell me what this power is for the next term, for the second term? What's the power of x in this?
X power of 3.
X power 3, because we have x raised to power 4 in the numerator, and we have x power 1 in the denominator. So it's x raised to power 4 minus 1, which is 3. So the second term has x power 3. And just by doing that, you can actually figure out what the next terms are going to be. Because now we know we have a difference of -2. So we have x power 5, the x power 3. The next one has to be x power 1. Then the next one has to be x power -1. Then it has to be x power -3, and so on. Which one are we looking for? We are looking for a coefficient of x, that's x power 1. So we know this is all that we need. The very next term is the one that we need. That's all that we want. Okay. So this is the term that we need. So we expand just one more time. The next one is 5c2 into 3x whole raised to power 3 into -2 over x whole raised to power 2. And that's it. This is the term that we are looking for. We ignore everything else. We just simplify this, and that will give us our result. Okay. So let's simplify this and see what this gives us. When we simplify this, we get 5c2, which is 10, into 3x cubed, that is 27x cubed, into -2 over x whole raised to power 2. The negative gets removed because when you square it, the negative basically gets eliminated. 2 over x whole squared is 4 over x squared. Now we can simplify this. 10 into 27 into 4. What is that going to be? 270 into 4. That's 1080 times x, because we have x raised to power 3 here, x raised to power 2 here, x raised to power 3 minus 2 is x raised to power 1. This is what we have. We were looking for the coefficient of x. So what do we say about the coefficient? We say the coefficient of x, therefore, is equal to 1080. And that's all that we were looking for. This is our final result. So the idea is that we use the same formula. We just look at the first two terms. We find the pattern. It's always a linear sequence with constant difference. And we figure out where is going to be the term that we need. Okay. Now, in this case, it was pretty straightforward because the term that we needed was in the beginning. And that's actually going to be the case most of the times. But it becomes slightly trickier when the term that we need is maybe further away. Maybe it was the 7th term or the 9th term, right? Let's see how we're going to use the same method there and do it just as quickly as we did this one. Okay, but before that, let me know if you have any problem in this. Any questions on this? Is the method clear to everyone?
Yes.
Right. There is another way of doing this as well. That's using the general term formula. But I find that something that leads to you doing a lot of careless mistakes. But that's because that involves using some rules of indices that a lot of people unfortunately struggle with for some reason, and they end up doing careless mistakes doing the other method. So those of you who have done that other method using that general term formula, I would recommend that we do this that we're doing here. Let me show this with another example. Let's say we have this expansion now, question number 32 from the worksheet. Let's see how we can apply that same method to this as well. Let's see how we can do this. Question number 32 from the worksheet. Question number 32. Okay, so it says, find the term independent of x, the expansion of this. Okay, now let me copy the formula here as well. This is the formula that we have. Now, this is NC1, this is NC2, this is NC3, right? Now, what are we looking for? Yes, I will do that. So after this question, we will be doing the questions that you have. We will do that. This is the last concept that we have, and then you can let me know if you have any problems anywhere, okay? All right, so we need to find the term independent of x. First of all, what does that mean? Independent of x. It means the term that does not have x in it. So the constant. Independent of x means the constant term, which we can say is x raised to power 0. So that is what we are looking for. We're looking for x raised to power 0. The term that has x raised to power 0. So how do we do that? We're just going to use the same formula to expand this thing up to only the first two terms. So 4x cubed plus 1 over 2x whole raised to power 8. How do we expand this? The first term is 4x cubed. The second term is 1 over 2x. N is 8. Let's input values here. A raised to power n, that's 4x cubed raised to power 8. Okay? Plus nc1, what's n? N is 8. 8c1 into 4x cubed whole raised to power 7 into 1 over 2x. And now you're going to stop here. Okay? Now you're going to just stop here and look at the pattern that emerges. Let's look at the pattern that you get here. What's the power of x in the first term? X raised to power 3 whole raised to power 8. What does that become? This is x raised to power 24, right? Please make sure that you have your indices rules sorted. X raised to power 3 whole raised to power 8, that's not x raised to power 11. The powers are not added here, they're multiplied, okay? X raised to power 24, that's the power that we have in the first term. What about the second one? What do you think this is going to be? Anyone? What's the second one? 20, right? It's not 21, it's 20. You have 21 from the numerator. 3 into 7, that's 20. 21, sorry. Then you have an x in the denominator here as well. So that power is subtracted. 21 minus 1, that is 20. So the second term has x raised to power 20. And now you got the pattern. If this is x to power 24 and the second is x power 20, we know the next one is going to be x raised to power 16 because we have to subtract 4 in order to get the next one. And the next one is going to be x power 12. The next one is x power 8. The next one is x power 4. And then the next one is x power 0. And that is the one that we actually need. That's the one that we're looking for. Okay. Now, how do we find that term? Now, one possibility is that you just keep writing this and just get to that term, or you can make this quicker. How do you make this quicker? Remember when we started binomial expansion, I showed you a pattern that you have here. Remember this? Every term in this formula looks like this. NCR into a raised to power n minus r into b raised to power r. Every term looks like this. This is actually the general term formula that we have. Every term is of this form. NCR into a raised to power n minus r into b raised to power r. First term, second term, third term, fourth term, every term looks like this. The only difference is the value of r is changing. You have r equals 0, r equals 1, r equals 2, and so on. So one possibility is that you just remember this NCR into a raised to power r, n minus r into b raised to power r. You remember this form. What was that form? You write that here, NCR into a raised to power n minus r into b raised to power r. If you remember this form, you know this is r equals 0. Remember, it starts from r equals 0. The next is r equals 1. Next is r equals 2, then 3, 4, 5, 6. So we are looking for the term that has r equal to 6. Just input r equal to 6 here, get 8c6 into a, which is 4x cubed, into 8 minus 6 into 1 over 2x whole raised to power 2, and that will give you the result. What's 8c6? Can somebody tell me what the value of 8c6 is? 8c6?
28.
28.
28? 28 into 4x cube whole raised to power 2 into 1 over 2x whole raised to power, I'm sorry, there's something wrong here. 8 minus 2, it's supposed to be 8 minus 2. So this is 6. How did I figure that out? So I did a mistake here. How did I figure that out? Because the total was not turning out to be 8. Remember, I told you these powers have to sum to 8. So one has to be 6 and then the other has to be 2 here. What do we get from this? We get 28 into, I'm sorry about that. It's the other way around. R was supposed to be 6. R was 6 here, 8 minus 6. And then this was supposed to be 6. It's the other way around here. Yeah, again, it adds up to 8. So 28 into 4 squared, that is 16, and then x cubed squared, that is x raised to power 6, and then 2 raised to power 6 is 32 into 2, that's 64 into x raised to power 6. X raised to power 6 and x raised to power 6 get cancelled, and you're left with 28 into 16 over 64. 16 over 64 is 1 over 4. 28 over 4 is 7. And that is what we were looking for here. So after you have figured out this pattern, one possibility is that you remember this form NCR into b raised to power and NCR into a raised to power n minus r into b raised to power r. Just figure out what the value of r is going to be and then input that here. Or you can also do this. If you don't remember this formula is going to be there, of course. You have that formula there. All you need to do is just write what is going to happen to this thing. It's 8c1 right now, right? This value. What about the next one? The next one is going to have 8c2, then you have 8c3, then you have 8c4, then you have 8c5. Then the term that you need would have 8c6. That's the one that we're looking for. And then you put the other powers according to that. How do you do that? You have 4x cubed and 1 over 2x. What power are you going to put over 4x cubed? 7 is reducing. 7, then the next is going to be 6, 5, 4, 3, 2. So this is going to be 2 here. Power of 1 over 2x. If this is 1, this is also 1. The next is going to be 2, 3, 4, 5, 6. This is going to be 6 here. So even if you don't remember that general term formula, you can actually just figure this out using the pattern directly, and then you can just ignore everything else, just simplify this thing, and that would simplify to 7 just like it did there, and that will be your final answer. All right, so this pattern is going to be extremely helpful You can just look at the pattern that you have in the terms and then use that to find that specific term that you're looking for. Is that okay? Any problem with this? Any questions, anyone?
No.
So the powers are always going to follow a linear pattern. Okay, they're going to be in a linear sequence like this, with the difference being constant. Okay, that's great. Now let's quickly do one more question that somebody asked me last time. I'm not sure who that was. Question number 33. Right. So now that we know how to find a specific term in an expansion, now we can do this question as well. Question number 33. Let's try this, and then we'll do the one that Ira asked about. That's question number 8. We'll do that today as well. And then hopefully in the next class, we can start our next topic, unless you have any questions. So you have to make sure now that you complete the worksheet. And I would recommend that you submit the worksheet by tomorrow night. Okay. The assigned questions, you should complete them, take pictures of them using maybe Cam Scanner or any similar app, make a PDF and upload them on Google Classroom, please. This is extremely important. In order to get benefit from this course, you have to do practice. You have to do all the assigned questions. That's the bare minimum. Okay, you have to do the assigned questions. Make sure that you let me know if you have any problems in them so we can discuss them in class and then submit them as well. Okay, of course, you have to check your answers from the marking scheme, but you have to keep submitting them as well. All right, let's have a look at this question, question number 33. Question number 33 from the worksheet. It says, find the coefficient of x squared in the expansion of 1 plus x squared into x over 2 minus 4 over x whole raised to power 6. We need to find the coefficient of x squared in this expansion. Okay, now, remember we did a similar question earlier when we have two things being multiplied like this. The very first thing that you need to do is you need to figure out which terms are you going to need from this expansion. Okay, one idea is that you expand the whole thing. You can do that if you want, but that's going to take more time. It's power 6. Power 6 means you're going to have 7 terms in the expansion. One way is that you expand everything or expand all 7 terms, simplify everything, but that's going to take longer. Okay, so a more efficient way of doing this is you find the terms that you are going to need from this expansion. Now think about this. 1 plus x squared. So this is something that does not have any power in it. We don't need to use binomial for this, right? This is going to get multiplied with this second bracket that has something in it, right? Now the problem is this has power 6 in it. We would need to expand it. Now, rather than having to expand the whole thing, what we do is we figure out which terms are going to give us x squared, because that's the only thing that we're looking for, right? We're just looking for the coefficient of x squared. So we figure out how are we going to get to this x squared, right? That's what you want to figure out. We have 1 here and we have x squared here. What do we multiply 1 by to get x squared? Which power of x do we need to multiply 1 by to get x squared? We need to multiply it by x squared, right? So that's one term that we need from this expansion. We need the x squared term. Okay. What do we need to multiply x squared by to get an x squared? Well, square will need to be multiplied by a constant, right? That's when we can get x squared. So what does constant mean? Constant means x raised to a power 0. So from this expansion, we need these two terms, x squared and x raised to power 0. These are the only two terms that we want from this expansion. We don't need anything else. Does that make sense? So that's the first thing that you would do in problems like these, where you have two expressions multiplying. You would start from the one that does not have a power, the one that you do not have to use binomial on. You start from that and you think about the terms that you're going to need from the other expansion, from the other bracket. Is that okay? I hope that makes sense. So from this expansion, you need x squared and x raised to power 0. So now let's just focus on this. Let's focus on that bracket. Let me actually write it fully now. It was x over 2 minus 4 over x whole raised to power 6. So we need x squared from that and also x raised to power 0. These are the two terms that we are interested in from that expansion. So now we find those two terms. So we have x over 2 minus 4 over x. We'll come back to this after doing this expansion. Whole raised to power 6. Let's figure out those two terms. How would we do that? We would use the formula that we have and find the pattern. This is the binomial formula that's given in the formula sheet already. We will have this in front of us when we're doing this in the exam. And we would just write down the first two terms. Okay, a raised to power n. That means x over 2 whole raised to power 6. Remember, this is a. B is minus 4 over x. Do not forget the minus sign there. And then n is 6. Okay, we're just inputting values in the formula. X over 2 whole raised to power 6 plus 6c1, we're looking at this one now, into a raised to power n minus 1. That means x over 2 whole raised to power 5 into b, which is minus 4 over x. Let's find out the pattern. What's the power of x that we have in the first term? It's x raised to power 6. The first term has x raised to power 6, right? What about the second one? X raised to power 5 divided by x. That's x raised to power 4. So that's the next term that we have. So we have the pattern now. The first is x raised to power 6. The second is x raised to power 4. So there's a difference of negative 2. So the next one, therefore, is going to be x raised to power 2. We need that, right? That's the term that we were looking for. And the next one after that, that is going to be x raised to power 0. We also need that. So these are the two terms that we need. So we just expand to two more terms. The next one is going to be 6c2 into x over 2 whole raised to power 4 into minus 4 over x whole raised to power 2. Okay, that's one term that we need. Then we find the next one as well. That's 6c3 into x over 2 whole raised to power 3 into minus 4 over x whole raised to power 3. That is what we need. Now we ignore everything else. We just focus on these two terms because that's all that we need, right? From that expansion, we are just interested in these two terms. We ignore everything else. Okay, because we needed x squared and x raised to power 0. That's what we want. Now let's simplify these two terms. 6c2, what's that? 6c2 is 15 into x raised to power 4, 2 raised to power 4, that's 16, into minus 4 whole squared, that is 16, divided by x squared. And then the second one, that's 6c3, 6c3 is 20. Again, you can do that on your calculator. X cubed over 8 minus sign and then a cube. Remember, odd powers, the negative sign stays there. If you have even powers, power 2, power 4, the negative sign gets eliminated. But with odd powers, the negative sign stays there. because minus into minus into minus, that's still minus. 2 minuses become plus, but 3 minuses are still a minus, right? So this gives you minus 4 cubed, which is minus 64, divided by x cubed. And that's it. Now we simplify this. 16 and 16 get cancelled. The first term is 15x squared, right? X raised to the power 4 over x squared, that's 15x squared. And then what about the next one? It's going to have a negative sign, 20 over 8. 64 over 8 is 8. 8 into 20 is 160. So we have 160, and x cube and x cube get cancelled. So that's a constant that we have. These were the two terms that we wanted from this expansion. That's all that we wanted from that. All right. Now we just put them back. This is what we started from. We wanted the coefficient of x squared at the end, right? So remember the question. We want the coefficient of x squared in this product. So we have 1 plus x squared into this. We say this can be written as 1 plus x squared multiplied by, we ignore everything else. We're ignoring the rest of the terms. We're just focusing on these two terms. 15x squared minus 160. We don't care what else was there, right? And now we just multiply them. Again, we don't even need to multiply this whole thing. We can just do the products that we need. Remember, 1 needs to be multiplied with 15x squared to get the x squared term. X squared needs to be multiplied with the constant. Just need to do these two multiplications, 1 into 15x squared, and then x squared into minus 160. Do not forget the negative signs there. And that gives you 15x squared minus 160x squared. That results in minus 145x squared. So what's the coefficient of x squared that we were looking for? The coefficient of x squared, therefore, is minus 145. That's what we wanted. That's our final result. Yes, Aram, that's correct. That's our final answer, minus 145. If you wanted, you could do this complete multiplication as well. That's okay, but that will just take longer. That's how you would do it. I hope that makes sense. By the way, just something that I thought about when I was doing this calculation. You can actually do this directly on your calculator, this calculation. The problem is you have x here, so that creates a problem when you input this in your calculator. If you want to get 15 directly from the calculator, what you're going to do is, on your calculator, you will just write down 6C2. If you don't want to do this manually, if you want to do this directly on your calculator, how would you do that? You write 6C2, okay? Make sure that you use brackets around that, otherwise it causes some problems because, yeah, sorry. Let's ignore that. Just make sure that you write this in brackets, otherwise this 2 will be considered a part of the next thing that you write. So be careful about this, 6C2. And then when you're putting this in your calculator, in place of x, just put 1. So wherever you have x, put 1 there. Okay, so in place of x, you put 1 here. So you have 1 over 2, whole raised to power 4. Then you have minus 4. Again, you have x here, put 1 there, whole raised to power 2. You can put this whole thing on your calculator. You will get 15 directly. Okay, so the number, the coefficient, you can calculate from the calculator directly like this. You don't have to do this manually. That's not necessary. And then you just have to figure out what power of x is going to be there. So that's x raised to power 4 divided by x squared. That gives you x squared here. Okay, but if you want to calculate that number directly from calculator, this is how you would do it. In place of x, just put 1. And make sure that you're using your brackets correctly. Everything needs to be in brackets properly. And that will ensure that you get the correct result. Okay, you can try this a few times. Make sure that you are not doing any careless errors. If you think you end up making careless errors. If you do it this way, then do it step by step. Add another step like this, like I did. Write 6C2 first, and then simplify this first, and simplify this first, and then multiply them step by step. So that's individual choice. You can see which one works better for you. All right, so that's the coefficient of x squared that we end up getting from this. Let me know if you have any problems in this. Otherwise, I'll move on to the next one, the last one for today. Any problem with this, anyone? Any questions?
No, sir.
No questions? All right, I hope that was clear. Then let's move on to the next question then. Okay, so Ima is asking about question number, was it Ima or Ira? Yeah, Ira asked about question number 8, part 2. Let's do that. Let's end the class with that question, and then we are done with this whole topic. Make sure that you complete the worksheet. You have 2 days now. Try to submit it by tomorrow night. In case you have any questions still, we can discuss them in our next class. If I think they're tricky enough, we can discuss them in the next class. If they're not that tricky, we can discuss them offline, outside class, maybe on WhatsApp. I can explain to you in a voice note, and we can move on to the next topic. But that's for the next class. Make sure that you complete this worksheet, please. Otherwise, attending these 3 classes is not going to be of much benefit, because after a week, you're going to forget everything. Unless you do practice of the questions that we did. So please make sure that you do that. Okay, question number 8. Let's have a look at this. Question number 8 from the worksheet. Let me copy the formula here as well. Yeah. So again, this formula is going to be there in the formula sheet. You can keep this in front of you. All right. So it says find the first 3 terms in the expansion of 2 plus 3x whole raised to power 5. Okay, the second part will need us to use this. The second part is going to require us to use the first part. So we will have to do the first part as well. Let's do that quickly. We need to find the first 3 terms in this expansion in ascending powers of x. It will automatically be in ascending powers of x when we do this. Let's try. 2 plus 3x whole raised to power 5. We need to do this expansion. Again, let's compare. In place of a, we've got 2. In place of b, we have 3x. In place of n, we have 5. A raised to power n. So that's 2 raised to power 5 plus nc1. That's 5c1 into 2 raised to power 4 into 3x raised to power 1 plus 5c2 into 2 raised to power 3 into 3x whole squared. Now we already have 3 terms, so we don't have to go any further than this. We can just stop at this point and simplify everything. 2 raised to power 5 is 32 plus 5c1 is 5 into 2 raised to power 4 is 16. 16 into 3x plus 5c2 is 10. You can do that on your calculator. I just tend to remember this because I've done this and done 5c something or 6c something. Once you've done enough practice, you start remembering at least the 5 ones and 6 ones. The bigger numbers are hard to remember, but these are easier. 5c2 is 10, so 10 into 2 cubed, that is 8, and then 3x squared is 9x squared. Okay, now we just simplify this. This gives us 32. 80 into 3, that's 240 to 40x plus 80 into 9, that should be 720x squared. That's the first part. That gets you 3 marks. In the first part, we just had to do this expansion for the first three terms. All right. Now, the second part says, hence find the value of the constant a for which there is no term in x squared in this expansion. Okay, so it's very similar to a question that we did previously as well. Yeah, we did not do this question in particular, but we did a very similar question to this. Hence means you have to use the previous word. Okay. In the previous part, we've already expanded this thing up to the first three terms. We need to find the value of the constant a for which there is no term in x squared. Whenever it says there is no term in a particular coefficient, that means in a particular power, that means the coefficient of that power has to be 0. So no term in x squared means you need to have 0 x squared. The coefficient of x squared has to be 0. That's what it means, because if you have 0 x squared, 0 into anything is 0, you will not have any term in x squared then. So all we have to do is find the coefficient of x squared in this expansion and put that coefficient equal to 0. That's all that we need to do. Okay, now let's do that. So what do we have here? 1 plus ax, 1 plus a times x multiplied by 2 plus 3x whole raised to the power of 5. 1 plus ax into this thing. We can either think about which terms we need already first, or since we only have 3 terms expanded here, we can just use them as it is. Let's do that thinking actually, because that helps in most of the questions. So what are we looking for? We're looking for the term in x squared. How do we get x squared? What would we need to multiply by 1 to get x squared? We need to multiply x squared with this. What do we need to multiply x with to get x squared? We need to multiply this by x. So these are the terms that we really need from the other expansion. We're looking for the x squared term and the x term. We already have them here. If we did not have them, if we wanted, for example, x cubed, then we would have needed to have another term as well. But here we just need these two terms, x and x squared. So again, if you want, you could just ignore this 32 now, because that's not going to give you x squared in any case, and just focus on these two terms. Or you can do the whole product as well. That's your choice. So let's ignore everything else. All that we need is, so these dots are not important. It's just a better way of writing this, but you can just not put them there as well. That's your choice. We're just focusing on these two terms. Okay. How do we get x squared now? Again, we can ignore everything else. Just focus on x squared. How can we get x squared? 1 will need to be multiplied with this. Ax will need to be multiplied with this, right? Constant will need to be multiplied with x squared, and x will need to be multiplied with x if we want x squared as the final result. So we have 1 into 720x squared plus ax into 240x. Let's simplify this. This gives us 720x squared plus 240 ax squared. Now remember what we want at the end. We want the coefficient of x squared to be 0. So we want 0x squared. That is what we want. Okay. So we need to put the coefficient of x squared equal to 0. What's the coefficient of x squared in this case? The coefficient of x squared is, if we take x squared common and find the coefficient of x squared, that is 720 plus 240 times a. So we just need to put this thing equal to 0. This has to be equal to 0. Right? So we say 720 plus 240a. This has to be 0. And just find the value of a from this. What do we get? 240a equals minus 720. The value of a turns out to be minus 3. That is what we were looking for. Yeah, so that's correct. That's -3. Is that okay? So when you have a product like this, you think about which terms do we need from that expansion and just focus on those terms. And in this question, it said, find the value of a for which there is no term in x squared. No term in a particular power means the coefficient of that power has to be 0. Okay? That's how you would approach this. Any questions on this? So I expect you now to complete the worksheet and upload that on Google Classroom so that you can also figure out what problems you have. You can ask about those problems in class or in the WhatsApp group. But attempting those questions is really important. Okay, otherwise it'll just be like your school classes that you've been attending for 2 years and not practicing yourself. That's the main problem, right? If you don't practice, there's no point. You will forget everything. You just forget everything even after a week. So make sure that you do all the questions. That will help you retain everything. All right. Any problems, anyone? No? Okay, so if there are no questions, that's it. I'll see you again in the next class. Yeah, so Aram, you have to at least attempt the questions that are assigned. Okay, at least attempt the questions that are assigned. My recommendation would be considering the time that you have left before the exams, this is how you're going to go about your practice. Attempt all the questions assigned from the worksheet. That's your first step. That will clear all concepts in a particular topic. And then for further practice, focus on doing recent papers. You can pick up a topical book, any publisher, Read and Write, MS, whatever. You can find some worksheets online as well with recent papers. There's one at Papa Cambridge. I'll actually find that and share that link with you as well. You can find topical worksheets there for recent papers, 2020 onward. After you're done with the assigned questions, more practice should be done from recent papers, 2020 onward. Okay, that's what I would recommend. But again, don't leave this for later. Start now. Start right now, because you don't have enough time. You have enough time, but don't have a lot of time to waste anymore. Okay. All right. I'll see you again in the next class then in office.